My name is Ryan Jason S. Angulo and I'm going to report about fluids at rest. What are fluids? Fluids are substances with no fixed shape, has the ability to flow and yields easily to external pressure. Fundamentals properties of fluids. First is density, with this symbol called ρ. Mass per unit volume. So ρ is equals to mass over volume, or it is kilograms per cubic meter, and our constant is the density of water is equals to 1000 kilograms per cubic meter. For example, what is the density of a 25 gram substances with a volume of 0.005 cubic meters? To solve for the density, it is equals to mass over volume. Then we will convert this into kilograms, which will be equal to 0.025 all over the volume of 0.005. So using our calculator, we will have an answer of 5 kilograms per cubic meter. We'll also solve for unit weight, or with the sign of gamma. Weight per unit volume. This is the definition of unit weight, or relative weight over a specific weight. So gamma is equals to weight over volume, and its unit is Newton per cubic meter. And for water in SI, it is equals to 9,810 Newton per cubic meter, or 9.81 kilonewton over cubic meter. And for English, unit weight of water is equals to 62.4 pounds per cubic feet. Example, what is the unit weight of a 30 gram substances with a volume of 0.006 cubic meters? And here we are asked to find the unit weight. So unit weight is equals to weight over volume, where our weight is equals to mass times gravity. We substitute our given, it will be 0.030 kilograms and times our gravity 9.81 all over our volume 0.006 cubic meters. And as we input it in our calculator, we will get the answer of 49.05 Newton over cubic meter. Then I will discuss about specific gravity. Specific gravity, it is the ratio of the density unit weight of a substance to the density unit weight of water, or this is the formula. Specific gravity, or Sg, is equals to ρ, or density of a substance over density of water, and equals to gamma, or unit weight of a substance over unit weight of water. And here we have the example. What is the specific gravity of a 30 gram substance with a volume of 0.006 cubic meters? So we are going to, if we will be using density, specific gravity is equals to density of the substance over density of the water, which will be equals to 0.030. This is our over 0.006, our volume, all over the density of water, which is already given. This is 1000. And if we will calculate this in our calculator, this should be equal to 0.005. That is our specific gravity with this substance in the given problem. And if we will be using unit weight, specific gravity will be equal to and we are going to get the unit weight of the substance from the given. We will convert 30 grams to kilograms. This will be 0.030 times 9.81, our gravity, over volume, to get our unit weight of the substance all over the unit weight of the water. And this will also be equal to 0.005. That is how we get our specific gravity. Here we are asked about, this is also another fundamental properties of water, about fluid pressure, or P. It is the force over unit area. So fluid pressure is equals to force over area, or equals to, and we have unit Pascal or PA. Total pressure is equals to P atmospheric pressure plus, this is our gauge pressure, this is our rho, gravity, and our height. And if we are using density, and this is if we are using unit weight. And this is our gauge pressure. And for example, two divers have the same mass, 50 kilograms, and dives into the water. Compute the barometric pressure each of them experiences. Diver A went 10 meters deep and diver B is only 6 meters deep. So in here we are going to compute the total pressure. So our total pressure is equals to so at A, we are going to solve for A. So total pressure of diver A that went 10 meters deep, and we have our constant atmospheric pressure that will be already given, and it is a constant. This is 101,325 Pascal plus our density of water, and we should also know about it. It is also given 1000 times gravity, also a constant, and 10 meters deep. This will be equal to 199,500 425 Pascal. And for our diver B, we are also going to do the same. Our atmospheric pressure plus our gauge pressure. So atmospheric pressure is 1001,325 Pascal plus our water density times gravity and times the 6 meters deep. This will be 160,185 Pascal. And Pascal's principle, any pressure applied to a confined fluid will be transmitted undiminished to all parts of the fluid. So hydraulic multiplication of force, and here we have pressure 1 is equals to pressure 2, and we have also our equation, this one. Now I'm going to discuss about buoyancy. It is a phenomenon wherein a body immersed in a fluid experiences an upward force called the buoyant force, which tends to lessen the body's weight in the fluid compared to its weight in air. Archimedes' principle, whenever a body is immersed fully or partially in a fluid, a buoyant force will act on the body that is equal to the weight of the fluid displaced. Note that it is a buoyant force is also equal to the weight of the fluid displaced. For example, a 5 kilogram block of aluminum with a density of 2,700 kilogram over cubic meter is attached to a rope. Determine the following. A. The tension force in the rope if the block is in a vacuum, meaning there is no other medium acting on the aluminum. B. The tension force if the block is in air and density is equals to 1.29 kilograms over cubic meter. And C. The tension force if the block is in the water with density of 1,000 kilogram per cubic meter. Now we are going to solve for A, for tension, and this will be A. This is tension when the block is in vacuum. And here we will draw our aluminum block with a tension, and it has also its weight. These are the forces acting on the aluminum block. So where the tension force is equal to weight also. And as we know, weight is equals to mg, and we can already solve for the tension that 5 kilogram 5 times our gravity. So tension is equals to 49 newtons. Then we are going to solve for B. in the problem, the tension force if the block is in air. So we're going to solve for B. What is the tension when the block is in air? This is the tension. This is the aluminum's weight. And this is the buoyancy force of air. So by summation of vertical forces, so tension plus buoyancy force of air minus weight is equals to 0. So we can already solve for our tension, that is equals to weight minus buoyancy force of air. So we will get our buoyancy force of air. Buoyancy force of air is equals to the P air times gravity times the volume displaced. And we will also get the volume displaced so that we can get the buoyancy force of air. So for volume displaced, so we already have our given on the problem. This is the density of the aluminum. So by that given, we can get the density of aluminum is equals to mass of the aluminum over volume of the aluminum. So in the given, we have 2,700. That is the density of the aluminum, and we also have given of the mass of the aluminum over volume of the aluminum. So volume of the aluminum, by using algebra, we can get 0.00185 cubic meter. This is the volume of aluminum. This is also equal to the volume displaced. And now we can solve for the buoyancy force. We can also solve for the buoyancy force of the air. So buoyancy force of air, it is equals to, by our given on the problem, this is the density of the air. So 1.29 kilogram over cubic meter times our gravity, 9.81 meter per square second, and our volume displaced, which is 0.00185 cubic meter. So the buoyancy force of air will be equal to 0.0234 Newton. And from letter A, that is the tension force of the rope that is in vacuum. So we can get the tension by subtracting the first tension that is in vacuum minus the buoyancy force of air, which is 0.0234 Newton. This will be equal to 48.9766 Newton. And lastly, we are now asked the tension force if the block is in water, and the given of the density of water is 1000 kilogram over cubic meter. So this will be C. This is the tension when the block is in water. So tension, as we already know, it is the weight minus buoyancy force of the water. So buoyancy force of the water is equals to density of water times gravity times the volume displaced. We already have solved for the volume displaced before this problem. So the volume of aluminum, it is equals to 0.00185 cubic meter. Then we can substitute the values to get the buoyancy force of the water. 1000 kilogram by the density of water over cubic meter times 9.81 gravity times our volume displaced. This will be equal to 18.1485 Newton. And we will subtract this tension from the original tension, 18.1485. So the tension if the block is in water will be 30.8515 Newton.